So here I'm just basically going to explain how you find the intersection of two lines. Let's say we have a line passing through a point P, which we can just say 1, 0, and 3, and it also passes through point Q. We can give the coordinates 2, 1, 4. So and then that's the first line. You can just say it's line 1, and we have another line. Now instead of giving you the points, we can give you like the parametric equations of that. Let's say minus 7 plus t, and then y equals minus 20 plus 2t, and then we also give you z as minus 5 plus t. So now it doesn't matter how they give you, they can give you in any way. But now what I'm gonna do is like I'm gonna convert each line. I'm gonna give each line in symmetric form. Now try to like see if you can do this in symmetric form. Okay, so now for line 1, let's write the vector form of that. 2 minus 1, that's 1, and then 1 minus 0, that's 1, and then 4 minus 3, that's 1. So we'll have vector v as that, and then that means that from then we can get the symmetric form to be x minus you can take any coordinate, but let me just pick this one. So I'll have x minus 1 over this, and then this will be the same as y minus 0 over this one. So it's just 1, and then we'll have z minus 3, which is just this one, divided by this one here. So that means that we'll have x minus 1 equals y equals z minus 3. So that's for line 1. And now line 2 in symmetric form, symmetric equation. Line 2 will have like we just solve for t, in each equation. Now here if we solve for t, we're just basically going to have x plus 7. And here if we solve for t, we're just going to have y plus 20 divided by 2. And here if we solve for t, we're just going to have z plus 5. So you have a symmetric equation of the first line, and you have a symmetric equation of the second line. So now what do you do from then? Remember, we're looking for where these two lines intersect. Where do they intersect, these lines? So when you find the intersection, you just take this and you let it, oh, okay, I further simplify that, but it doesn't matter. And this is the same as this. So you just take one equation there and you equate that to equation 1, which is just x minus 1 equals y. Then that will be your equation 1, and then you take this other equation here. Remember, I'm only taking the equations that only consist of x and y only, because from then I can solve for x and y. You see what I'm doing here? So then you have y plus 20 divided by 2. Well, this is 2. So now this will be the second equation, and then from then this one is simplified, so we can just substitute substitute 1 into equation 2. So that means we're gonna replace y with x minus 1 plus 20, because I basically just replace y with x minus 1, and then I have x plus 7. That will be the same as x minus, or positive, minus 1 plus 20 is going to be positive 19, and then from then you divide by 2, and then we can multiply both sides by 2. Then when we multiply both sides by 2 times 2 times 2, when we multiply both sides by 2, we get 2x plus 14. That will be the same as x plus 19. And then from then we can take this that side, then we just have x, and we can take this that side, then we'll have 19 minus 14, which will just simplify to 5. So that means that x equals 5. And then remember, y equals x minus 1, so y will be 5 minus 1. That will give us 4. And now how do we get z? From this equation, we can take an equation. Remember, from this equation, the simplified version of the equation is this one, y equals z minus 3. You can take any, you can also take this one, any equation that you want. So remember, like here I say that y equals z minus 3. So y equals z minus 3. That means that z is equals to y plus 3. So that means that z will be 4 plus 3, which gives us 7. So those two lines will intersect at a point. Point of intersection will be x coordinate is 5, y coordinate is 4, and the z coordinate is 7. So that's where the two lines will intersect. So what you normally do is like you find you express each line in symmetric form, right? Symmetric equation, and you, if it's possible to simplify each equation, each line here, you express it as symmetric, at a form of like a symmetric equation, and then after that you just find the two equations from that. Solve x and y first, and after that you can be able to solve for z, and that's how you can solve such things. Now let's see if you understand. So let's say we have line 1, which is given by the equation 4, 5, 6 plus t into 6, 5, 4. Then we have another line which is given by let's say minus 2, let me just say 0 and then 2. Yeah, it seems fine like this. Plus let's say k, you can still write t, doesn't matter. So let's say 9, 4, 1. Now you have these two lines here. Now where will these two lines intersect? That's the question. Now pause the video and see if you can be able to solve this one. So now the solution to that, what I said is like first convert each line to symmetric equation. So what will be the symmetric equation of this line? The symmetric equation, line 1, the symmetric equation of that will be x minus 4 over 6 equals y minus 5 over 5. This will be equals to z minus 6 over 4. So that's the symmetric equation of the first line. And for line 2, try and see if you can like find the symmetric equation of that. Then you'll have x plus 2 over 9 equals y minus 0, which is just going to be y over 4. This will be the same as z minus 2 over 1, which just simplifies to z over 2. But let me just leave it like that, over 1. Still fine, you can simplify. So now now that you have the symmetric equation, you take this, that will be equation 1, x minus 4 over 6 equals y minus 5 over 5. That's the first equation. And then the second equation is just going to be x plus 2 over 9 equals y over 4, I mean. So that's your second equation. So now it's just a matter of like solving. It's perfectly fine. You can do it anyhow you want. You can just solve these two equations. So how do you think you'll be able to like solve these two equations? Now, from equation 2, you can solve it anyhow. From equation 2, we can like say x plus 2 over 9 equals y over 4, and then we can rewrite that as y equals 4 over 9 into x plus 2. We can rewrite that, and we can just call it equation 3 basically. Then we substitute equation 3 to the equation that we didn't work on, and we didn't work on 1. So you substitute equation minus 4 over 6 equals 4 over 9 into x plus 2 minus 5 divided by 5. And then from then it's just a matter of like of solving for x here. So now let's see how do we solve for x in this case. This side we're dividing by 6 and this side we're dividing by 5, but now notice that we still have the 9 as a denominator in this one. So what I can do is like say I have x minus 4 over 6, and what's 9 times 5? That's gonna be 45. And then I take the 9 in the denominator, so I have something like this, 4 into x plus 2. And then what's 9 times 5? That's going to be 45. Then we have something like this. Then we have something like this. And then I can further expand. This will be x over 6 minus 4 over 6 equals 4x. Then you divide that by 45. And then plus 8 over 45. And then what's 8 minus 45? So 8 minus 45. And then from then you just take that side. Then you have x over 6 minus 4x over 45, and then you take the negative 4 over 6 that side, which is going to be positive if you take it that side. So now it's positive, and now what's 8 minus 45? Obviously it's going to be negative. Let's see, 8 minus 45 is the same as minus into 45 minus 8. Then we have a negative here. Then we'll have 15 minus 8, it's about 7. Then we have negative 37, so minus 37 over 45. So then what do we have then? From here you can just solve for x. So x will be equals to 4 over 6 minus 37 over 45 divided by 1 over 6 minus 4 over 45. And how do you simplify this? Notice that the denominator here and the denominator here and the denominator is basically the same. So you'll have 4 into 45 minus 37 multiplied by 6 divided by 45 minus 4 times 6. Then you can work on that. 45 times 2 is 90, and times 2 again is going to be 180. And 37 times 6, you see, remember, you're not allowed to use a calculator on these things, so you need to work on them manually. So 37 times 6. So how can we express that? So we can just say 40 times 6. What's 40 times 6? 4 times 6, that's 24, and then we have that 0 there. But now 37 is short of 3 to be 40. So what's 6 by 3? 6 by 3, that's going to be 18. And then what's 240 minus 18? Can do the math there, and then we have 2, 3 minus 1, that's 2, and then we have 2, 2, 2. Minus 2, 2, 2, divided by 45 minus 4 by 6. What's 4 by 6? 4 by 6 is just going to basically be 24, and then you have 45 minus 24, which is just going to be 1, and then this one will be 221. Then you have this over 21. Okay, so now what's 180 minus 222? This will be the same. Space. Okay, so we have x equals 180 minus 222 over 21. So now 180 minus 222, remember 222 is greater than 180, so this will be the same as negative into 222 minus 180. So we have a negative there. So 2 minus 0, that's 2, and then 2 minus 8, cannot do that. Then we have 1 and 12. 12 minus 8, that's just going to be 4. 1 minus 1 is 0. Then we have 42. Remember, it's negative 42. Then you divide that by 21. 42 divided by 21 is 2, and don't forget the negative. That means that x equals minus 2. That means that x equals minus 2. And how do we get y? If we substitute minus 2, do you see that y becomes 0? Therefore, this implies that y equals 0. This implies that y equals 0, because if you plug minus 2 plus 2 is 0. 4 over 9 times 0, it's 0. And then how do we get z? How do we get z? Remember, here, y over 4 is equals to z minus 2 over 1. And then y is 0, 0 over 4 equals 0, z minus 2. Z minus 2 over 1 is the same as z minus 2. So, and then this is 0 equals z minus 2. Then you get the value of z to be 2. And that's how you can solve this. So these two lines, they intersect at a point. Intersection point will be, we found x to be minus 2, and we found y to be 0, and we found z to be 2. So this is where the two lines will intersect. Hopefully you learn something from this, and then we can see, like, you can try other problems with lines and see if you can be able to tell the intersection from that. Thanks for watching.